my honor to introduce our esteemed resource person of the today's session. So Dr. Matheswaran is an associate professor, Jansen's Institute of Technology, Coimbatore, and founder, Chief Executive Officer of Cine Unicorns Solar Technologies Private Limited, DP, IIT recognized. So Green Tech startup supported by Startup TN under Transit 6.0 and IIT Kanpur Social Innovation Lab 3.0. He is currently pursuing his AICT Industry Research Fellowship at the R&D unit of Tata Consumer Product, Mumbai. So working on translational research to bridge academia and industry. So Dr. Matheswaran hold a PhD in solar thermal system from Anna University and is a B certified energy manager with over 2 decades of experience spanning academia, industry, and entrepreneurship. He is having 26 SCA index publication with a cumulative impact factor of 93.6, more than 1,000 citations, and an H index of 21. He holds his 6th granted patent in solar thermal and renewable energy system, has co-authored books on solar process heating and energy efficiency. Dr. Matheswaran has received multiple innovation awards, including the Grand Onion Challenge, Idea for Change Challenge, Yukti Innovation Challenge, August EPAM grant supported by IIIT Hyderabad, Mapathon 2.0 supported by Medicup, TPI, ICAR, DMA PR, Gujarat, and Transit 6.0. His research work focus on solar air heater, jet impeachment technologies, and advanced solar drying systems that enhance product quality, reduce post-harvest losses, and optimize energy use in agriculture industry. As a mentor, innovation ambassador, and recognized PhD supervisor at Anna University, he is actively involving research, innovation, and startup culture while acting as a reviewer for leading international journal in renewable energy. Let us warmly welcome Dr. Matheswaran sir to present his session and share his thoughts with us today. Welcome you, sir.
Thank you, sir. Thank you. Shall I share my screen, sir?
Always.
My screen is visible to all. So my screen is, my PPT is visual to all. Yes, sir. Alexa, my screen is visual to all.
Yes, sir, it is visible.
Okay, okay, thank you. So, good evening to all present here. So, first of all, I want to thank the management, principal, directors, and Department of Mechanical Engineering of Adisangara College of Engineering and Technology to inviting me for this and give a presentation in the title of Innovations in Solar Dryers and Promoting Energy Efficient Agro Processing. So, it is one of the important topic in the modern era, especially all the developed and underdeveloped countries. This topic falls under the SDG goal of 7, 9, and 11. So, it's a more important topic. So once again, I thank the organizing team to give me an opportunity to discuss about this topic. Thank you. So we will start our discussions. So today's agenda is the actual topic is innovation in solar dryer. So I will start my talk with what is meant for innovation, why it is important, and how the innovation should be systematically developed. Then what is the role of innovations in startups? So that is the first topic we have to discuss. Then we move on to why the solar heating is very important, especially in industrial processing, especially in agro industries. Then we move on to what is mean for solar air heating systems, how to develop this solar air heating system. So that is the analytical model development. Then I have to discuss about company supporting farmers with the help of our own product patented technology, that is Shiny Jet Agri Dryer. So how we are started, how we are installed, what are all the challenges we faced when we go and install this type of product in the market. Then finally we have to go with one or two case studies, actually what we are doing in the market. So that is the agenda for the next 1.5 hours. So at present, all the institutes in higher educational institutions talking about this innovation. So you know that the right side corner I have a logo, that is Institutions Innovation Council. So to develop this Institutions Innovation Council, I request the participants to mute your mic, please. I have some echo. Okay, thank you. So at present, all the institutions. Okay. So what is innovation? So to develop the innovation, all the institute at present have this Institutions Innovation Council. So what is an innovation? So why the innovation is very important? So for that purpose, I show the rankings. So this is known as the left-hand side of the slide consists the innovation index, the global innovation index ranking. Look at there, Switzerland, Sweden, USA, Singapore, UK. So look at their rankings. They have a highest score in global innovation index. They are at the topmost position. So what this rank will indicate? It automatically indicates these ranking countries are developed countries. That what is meant for developed country? They are economically wealth. So if the country is economically have sufficient wealth, then we call as those countries are developed countries. So why these countries are so? Government of India think about this. Why these countries are developed countries? We are developing countries. So the major important thing is the economy of these countries are mainly depends on innovation-based entrepreneurship ecosystem. They are developed in these countries. They are developing a lot of innovative products. They sold out the products or services throughout the world. So they have huge revenue. So that's why they have better ranking in global innovation index, and they are in the position of developed countries. So government of India want at present the ranking of global innovation ranking for India is 40th position. We are in 40th position. Switzerland is in the first position. So India is at present last year, as per the last year ranking, we are in 40th position. So government of India want to attain within 10 rank before 2030. So for that purpose, we want to attain $5 trillion economy before 2030. So these are all the two important goals for government of India. So first thing, we have to get $5 trillion economy. Then second thing, we have to get good ranking in global innovation index. So if you want to attain these things, we also have to develop innovation-based entrepreneurship ecosystem within the country. So we are also have to develop our own products, that is make in India and made in India. So for that purpose, we have to develop this innovation culture throughout the country. So for that purpose, one of the steps, what they do means, we have the biggest strength of India is the youngsters. So where these youngsters are gathered together, especially in higher educational institutions. So if we motivate these students and faculty members towards innovation, definitely 1% of the students or faculty members are convert their research work into an innovation means definitely it makes huge change. So we are also develop our own product. Definitely we are also able to attain the $5 trillion economy. We are also will become get good ranking in global innovation index, and we are also become a developed country. So that is the ultimate objective for all the higher education institutions. Through this Institution Innovation Council, we have to develop our innovation culture in this thing. So why I explain these things means, especially this system motivates. I am a teaching faculty, so this system motivates me to convert my research work as a product and start a small startup known as Shiny Unicorn Solar Technologies Private Limited. Okay, so that's why I'm starting from here. So at present, what is meant for innovation we have to discuss. So that is another important thing. So what is meant for innovation means any new product or modification in the existing product. It may be a product, or it may be a new process or service, or it may be a new source of supply or new type of market. For an example, entirely new product means you may know that Hyperloop. Hyperloop is at present developed by the students of IIT Madras. So that is entirely new product. Or if you make any modification in the existing system, that is common. You know that initially we have only ordinary dial type of phone. At present we have a smartphones, all these things. That is the modification in the existing product. That is also an innovation. So if you come for a new process, for initially we do conventional operations for manufacturing the product. At present we have a lot of technologies in additive manufacturing to manufacture any product. That is new process. Or it may be a new service. For an example, Swiggy, Zomato. Initially we go for hotels for food. At present the Swiggy, Zomato are new type of service they are providing. That is also an innovation. Or if you come up with a new source of supply, that means raw material, if you are into a new type, that is also an innovation. New market. For an example, you know that Nike shoe. Before Nike shoes, there is no sports shoes are available. Nike is the first company. They introduce shoes, especially for sports persons. So they will come for a new market. They develop a new market. So that is a new market. So innovation, what is meant for an innovation means it may be a product or modification in existing product, or it may be a process or new service or a new market. So anything in this category, those things are known as innovation. So simply what we call as innovation means anything new which have a commercial value, then that is known as innovation. So you have a theoretical conception and technical invention. Then if you sell those products to solve the problem of the society, those things are known as innovation. So as a researcher, we have to use our knowledge to convert the theoretical concept into an actual product, that is to be solve the societal problem, and it have a high commercial value means, then those things are known as innovation. Okay, so at present Government of India motivates a lot of youngsters to come for this type of innovation. So one of the innovation I have to quote it from medical industry. You know that diabetes people. So in diabetes, people have a lot of issues, especially a particular type of protein comes through the urine means their kidney may get failed. Previously, there is no tool to find those leakages. At present, an MBBS doctor come up with a new testing kit to identify. So that is the huge need. So a MBBS doctor come up with a solution for the problem. At present, the test kit is available throughout the country. The test kit is at present patented. So the doctor will give the revenue and the societal problem also to be solved. So so that is the ultimate objective. We have to focus on the societal problem, how that societal problem will be solved with our technical knowledge. So how to develop the innovation? So there are multiple case studies are available. So one of the way, it is not only way. One of the way is we may use the design thinking concept for the innovation development. So design thinking consists 5 steps. So if you use these steps first time in a linear manner, then in the further iterations, we may go with the steps in a non-linear manner up to the final product to be developed. So in the first step, one is empathize. So what is mean for empathize means if you want to develop any product or service, we have to view the problem in customer's point of view. So that is the very, very important thing. So if you are developing any product, it is not used by the customer means it is entirely wasted. So we have to view the problem in customer's point of view. For an example, you know that Tata come up with a product, a wonderful product known as Tata Nano car, but unfortunately it get failed. So why it is failed? They marketed the product as a poor man's car. So that is a major issue. So they are not view the problem. What is the customer's mindset? In India, we are purchasing the car only for our social status. But Tata Nano, they are marketed their product in the way of poor man's car. But no one want to get a poor man's car in those days. So that is the thing. So if you want to solve any problem, first view the problem in customer's point of view, that is empathy. So after that, the second step is define. So you have to define the problem. So some scientists, we get in one training program. In that one, the resource person say that if you write the problem in a proper manner, 80% of the solution you already getting. So that is the thing. So define the problem in a proper way. That is, when will the problem occur? What is the root cause for the problem? Who are facing the problem? What are all the existing solutions? Why the solutions are not fit to the existing problem? And what is the quantifiable and qualitative impact due to this problem our customer will get faced? So if you write all these answers for these questions, you may able to define the problem in a proper way. So that is the second step. Then third step is we have to develop the idea. So once you define the problem, we have to generate n number of ideas. There are a lot of idea generation techniques are available at present. So with the help of these things, we may generate the idea, and by formulating the idea generation matrix, we may select the particular idea. Then after that, we have to develop the prototype. So once you develop the prototype, we have to do analytical modeling, numerical simulations, then actual POC at lab scale, then field test, then it goes to the customers. That is prototyping. Finally, we give this product to various testing. Internal test, external test, black box test, white box test. In multiple ways, we have to test the product. So this is the effective way to design to solve any problem in an effective way. That is this concept is known as design thinking. Empathize, define, ideate, prototype, and test it. Okay. So among these things, the first time we may go with the step 1, 2, 3, 4, 5. So after fifth step, if you get failed, yeah, again you may come in which step we have to go. Again, we go to 1, 2, 3, 4, 5. In any way, we have to repeatedly do the iteration, and we have to get we will get the final solution. So this is the one of the effective way to develop the solution for the societal problems and innovation development. So at present, the startups any startups in any field, they are working in these areas, and they are developing the solutions. Normally, a startup company or innovation development may consist, this is the startup life cycle. This cycle is known as startup life cycle. It consists of 3 stages. One is valley of death stage. Then second one is early and later stage. The third one is called, the last one is called IPO stage. So I will explain how the system will work. So once you know these things, then we come for the actual topic, what we have. So initially, at the early stage of any innovation or startup, stage, we have an idea. We are not having any revenue. So this is the revenue side for the startup or the innovation. This is the loss side for the startup. So the positive Y is known as revenue, positive, negative Y is known as loss side. Okay. So at the initial stage, we are not having any. So we are at 0th position. So what happened after time? This is the x-axis will represent time. Okay. Right. So what happens initially? We are investing the time and investment. Our idea will be converted as proof of concept. That is known as POC. We are not having any revenue. Then after POC, we are converting into prototype. Then after prototype, we are launching in the market. that is known as the final product that is to be marketed. So once you sell it, we will get some revenue that is up to, when you come to this stage, that is known as we are attained the market, we are at the break-even point. That means the innovations, expenditure and the investment made by the company both are same. So that is known as break-even point. So that is the thing. So up to break-even point, from 0 position to this step, we are not getting any revenue. So that is known as valley of death stage. So if you want to develop any product in this stage, we have to go with various government grants. So after that, once you come for the break-even stage, then we move on to angel investors, venture capitalists to get huge revenue. Okay, in this step. So first the angel investors comes here. In this part, they invest the money. Our innovation will be launched to the market and we will get more profit. Once the angel investors goes out, then VC capitalists, venture capitalists comes into picture. They invest the money in the startup for further development. Once that stage also we crossed, means then our startup will be connected with initial public offering, that is called share market. Then it is open to the market. Then further the company will get developed. So this is the startup life cycle we have to do. So this is known as the innovation development. So in this, the next thing, how this solar drying in solar thermal system, any opportunity is there to develop a startup or innovation development. So that is to be discussed in the next details. Okay. So the next important thing is we move on to the requirement of solar thermal energy. So why the solar thermal energy is needed in the industries. So look at this chart. So the global energy consumption. So the global energy 360 exajoules. Okay. So among the 32% will be used by the industries. Among the 32% will be used by the industry, 31% will be transport sector, 24% by residential sector, and 13% by the other sectors. Okay. Among this 32% energy utilized by the industries, 74% of energy used in the industries are in the form of heat only. Only 26% of the energy consumed in these industries are electricity. So at present in the industries, among the 74% means it is 85 exajoules. So among the 74%, 45% is given by the coal, 30% is by the natural gas, 15% by the oil, 9% by the renewable, and 1% by the others. Okay. So you may take that 74% of this exajoules of energy required in the industries throughout the world. Among that, 30% of the energy is required at low temperature range. That is only 150 degrees Celsius. Then 22% comes under medium temperature range, that is 150 to 400. Then 48% that is required high temperature range, that is 400 degrees Celsius. So look at the data. So as per the data, industry required more amount of heat. So among that, 150 to 400 degrees Celsius, that is low and medium temperature, contribute nearly 52% of the heat required. So at present, we have the solar thermal technologies to convert the solar energy and to be utilized for the industrial requirement. So that is the first option. So there is a need and the technology also available. So with the help of the solar thermal technology, we may be able to supply the heat for the industrial processing. This is the first point. Then the second point is we at present all the developing and developed countries are bothering about 3 E's. What are the 3 E's? Means energy, economy, and environment. So all the developing countries want to develop their economy without affecting their environment and the economy. Okay, that is the major challenge for all the countries. So, and all the countries also want to reduce their global emissions to net zero emission before the year of 2050. So that is these are all the ultimate objective for all the countries in the world. Look at that. So in 2020, the greenhouse gas emission will be around 30,000 metric ton of CO2 equivalent. But we want to reduce it to zero within the year of 2050. That is the ultimate objective for all the countries. So if you go for net zero emission, the technical people, environmental people, and the economists find out that the solar contribution will be 69%, wind will be 18%, biomass will be 6%, hydro will be 3%, and geothermal will be 2%. So that is the thing. So look at there. So if the world want to go for net zero emission, the solar energy will contribute 69% for to reduce the emissions for net zero. So that is the another important thing that all the people are think about solar, right? Right. So these are all. So the another important thing is, so if you want to go for industrial process heating, the energy is available in the solar. The second one is all the countries want to go for net zero emission. So there is a huge potential energy in the solar. Then another advantage is, so it is a solar is the reliable source of energy. There is no transportation is required, no taxation. Then it is not affected by independent or geopolitical crisis. It will not affected by geopolitical crisis. So these are all the major advantage in solar system. So how to use the solar energy for energy generation means there are two technologies are available. One is solar thermal collectors, another one is solar photovoltaics. So what is solar thermal collectors means? We may directly convert it into heat energy using flat plate collectors and evacuated tube collectors. If you convert the solar radiation into heat energy means that is known as solar thermal collectors. Instead of that, if you convert the solar radiation into electrical energy, that is known as solar photovoltaics. So these are all the advantage. So at present, so we know there is an industrial requirement, there is an environment requirement, and there is an advantage of this solar with these points. But what is the actual contribution of renewable energy in the world means? Look at there. At present, the renewable energy share, the global renewable energy share for energy generation is nearly 23.7%. This is global in all the sectors. What is the share of renewable energy in industrial heating means? That is only 9%. This is for global, all the sectors. This is only in industries. 9% is only in industries. Among this 9% of industrial heating process, what is the contribution of solar here means? Look at the data. This is very unfortunate. So look at there. The solar energy contribution in industrial process heating is 0.001%. It is very, very less. So look at there. We know that there is a need of heat. We know we have to go for net zero emission. The solar also have these advantages, but still how much percentage of industries are using this energy means 0.001%. Why this happens? Why? So these are all the major limitations in solar. Why is high upfront cost? Initial investment is very high. So that's why longer payback will be there, and also lower awareness. So that's why the innovation is required in this area. So we know low cost, low payback, and effective technology to use this resource as a product for industrial process heating. So that is the major limitation in solar. That is higher initial investment and longer payback period. So that is the major limitations we have to overcome. Okay. Right. So at present, the solar heating for normally all the solar heating happens in industries are given in a general name known as ship system. That is solar heating for industrial process heating. So what is there means there are set of collectors. This collectors may heat the air or water or any other working fluid. Then the energy is stored in the energy storage unit, and the working fluid also go to the industry for process heating applications. So this system is known as ship systems. At present, nearly more than 500 industries are using this type of system for their process heating applications. So at present, the installed area, that is 4 lakh square meters, are installed throughout the world. So so the 4 lakh meter square is approximately equal to 280 megawatts of thermal energy. So that is known as solar heating for industrial process heating applications. So I will show some of the drying applications happens in ship systems in India. So look at there. It will be 230 meters square solar heating system for dal drying. So look at there. And for industrial process heatings, TI cycles, TVS motors, TAFE motors. So these people are using various flat plate collectors in their systems. So with the help of these flat plate collectors, they may able to produce the hot air for food product drying and also the industrial drying process. So with the help of this, TI cycles reduce 56 liters of oil per day. TVS motors reduces 64 kilogram of LPG per day. So these are all the smaller systems available in India, how they are using the solar heating for industrial processing. Okay. So this is the status of India. So what happens in rest of the world? So look at their ship system also used in that is mining industries. So in mining, so at present mining is very important thing. Why means there is a huge need of electric vehicles are at present are available. So we have to produce the batteries. So mining is very important work. So in mining we need a huge amount of hot water for the separation process. So for the purpose, solar water heaters are using, especially solar water heaters and solar air heaters are using for segregation purpose and drying purpose of these materials. So I will show two case studies. Look at that Gabe mining company. It is available at Silly. Look at the area, that is 39,300 meters square of the flat plate collectors are installed there. So it is approximately equal to 10 football grounds. Look at there. So look at there the size of the plant. So actually one water collector will be 2 cross 1, 2 meters cross 1 meter. That is the one water heaters area. So look at there, what is the total surface area? So if you use this, they may able to produce 54,000 megawatts of thermal energy. Among the total requirement of the energy requirement in the industries, 55% is shared by this plant. So it is actually at Silly. So it is a desert. So they may install such a plant to produce higher amount of hot water, especially in mining industries. Then I will go with another mining industry that is known as Scintilla Mining Factory. Here also look at there, the solar installed area is 16,742 meters square. So the annual energy produced by this system is 24,845 megawatts of thermal energy. Among the total requirement of energy, 55% is supported by this system. So these are all such a huge plants available in the world, especially for the supplying of hot waters. So I have one more plant, Ram Pharma. So Ram Pharma, it's available at Jordan. So it is a medical company. It's a pharma industry. They use Fresnel collectors. They use Fresnel collectors to produce hot steam. So the installed area is 550 meters square. The thermal power produced by the system will be 222 kilowatts of energy. So look at the operating temperature. This 210 degrees Celsius of steam is generated. The fuel saving will be 42%. So these are all the things, such a big plants available throughout the world for use for mining industry, pharma industry, all these things they are used. But India is an agriculture nation. At present, we are using this type of system, especially low temperature application, especially in agriculture drying. Okay, so in agriculture, one of the important thing is in India, throughout the world, the particular commodity, you may take moringa or any commodities, it may be produced during certain time period. So at certain time period, all the farmers are come up with a huge quantity of that product. So in the market, the product value get reduced. So if the product is not sold out, the entire thing will be get wasted. You know, the tomato and onions, how during certain time during the seasonal time, huge amount of products will be available in the market. During the half season, entirely the price will be go high, but the product is not available there. So that is the thing. So one data says in the wastage of onion in India, nearly about 3,000 crores per year. So that is the data we get it there. So one of the idea to reduce the post-harvesting losses in India is to dry those products and convert as a value go for a sold it out the market during the half seasons. So if you want to dry those products, so at present in the market, there are enormous dryers are available. So, electric dryers, heat pump dryers, conventional solar dryers, all these things are available. Okay. So our idea is how to use these solar dryers, especially for used by Indian farmers to convert their product into value-added product and sell it in a higher price. You already know that in the market, there is a huge value for dried product, especially at present Indian culinary systems, or especially the people in metropolitan cities and other countries, they want the food products ready to cook or ready to eat. So if you want to do such type of product, ready to cook products or ready to eat products, we need the agriculture products should be value added. So if you want to develop any value added agro products, it should be dried. Okay. So one of the major energy consumption process in value addition is drying process. Okay. So the specific energy consumption for drying process is very, very high. So that's why if you go with heat pump dryers or conventional electric dryers, the product quality is good, but the cost will be high. So that's why people are trying to develop various types of solar dryers for enhancing the efficiency of the drying system and to reduce the operating and production cost to the farmers and the food processing industries. So what is mean for drying? So if there is any product in a chamber, if you pass solar radiation or hot air, the humidity will be get reduced. Normally in all the agri products consist 80 to 90% of water. So if you remove the water, then you know that if there is no moisture, the product shelf life will be get improved. So how to do it, how to do this, how we have to remove the moisture from any product means, that's why the solar dryers comes into picture. So in olden days, initially the solar dryers are operated only in radiation mode of heat transfer. So at present, people are trying to go with developing of mixed mode technique. That means mixed mode technique means we may use radiation heat transfer and also convection heat transfer for enhancing the performance of the drying system. So if the performance of the drying system is enhanced, the quality of the dried product will be good. Then we may easily convert this agro products into value-added product as ready-to-eat products and ready-to-cook products that have a huge commercial value in the market. So, for an example, you take moringa. Moringa at present available in our local market. Per kg of moringa is not per kg, per bundle of moringa it takes around 10 rupees. Okay, per kg goes around 20 rupees. Okay, so if you dried it in a proper way, the market value you go for a moringa dried leaf, it goes for 200 rupees or 250 rupees in bulk purchase. If you go for online, you may check for the moringa price. Per kg of moringa powder in the market goes around 1000 rupees. So that is the thing. So that's why ordinary simple moringa, what is available in the market for 10 rupees, if you properly value add it, it have a lot of medical qualities. So without compromising the nutrition in it, if you dry it in an effective way, it have a huge market value. So that's why we have to there's a need for such type of product development. So solar dryers. So in the solar dryers, if you want to maintain the optimum temperature and optimum humidity in the mixed mode dryers are very effective when we compare with all other products. There are a lot of literatures are available. So the mixed mode dryers mixed mode means the dryer will operate on both radiation and convection mode of heat transfer. You know what is radiation and convection. So the convection, if we want to enhance the convective heat transfer inside the dryer, we have to supply the hot air in an effective way. So for the purpose, there is one important component in the solar dryer is known as solar air heater. So if you design the solar air heater in an effective way, and it is to be integrated with the dryer in a proper way, means then the dryer will get the dryer performance will be get improved. So for that purpose, various designs of solar air heaters are developed, and it is integrated with the solar dryers. So look at that. The first figure indicates. The first figure indicates the flat plate collectors, then parabolic type collectors. This is an evacuated tube air heaters. So these type of various air heaters are connected with the dryer for enhancing its performance. Initially, the drying chamber also cabinet type will be there, parabolic type will be there. Then north wall insulated greenhouse dryers are there. There are n number of designs are available. So people are working in these techniques how to improve the performance of the solar air heater with low cost. So that is the ultimate objective. Okay. So at present, so we know that the solar, what is the need for solar, why solar is required, and what is the objective for all the governments, and how it is used for various types of industries, especially pharma industry, then agriculture process heating industries, and also in mining industries. We know that. So at present, how many? So 40% of ship systems are installed in food and beverage industries. 12% of ship plants are industry for machinery, and 10% of installed in textile industries. So look at this graph. So at 2016 data, there are 4 lakh meter squares of solar ship systems are installed throughout the world. So look at this projection. So within the year of 2030, it is expected 1,300 million meter square of solar ship system to be installed throughout the world. It is expected to go for 2.2 exajoules to be produced. But due to COVID, there is some drop in this data. Okay, so there is a huge opportunity. So even though we know the requirement and there is a need, but still solar is lagging. It is not effectively integrated in all the industries. Why? Why means that is the thing. There is a lag of education and training. There is a lag of suitable planning and guiding tools. And there is a lag of awareness, and industries are only looking for long-term proven technology. For example, in a textile industry, if you need a steam means immediately the company go and purchase a boiler. They are not thinks about solar. So that is the thing. So then there is a high initial investment. The system costs also very high for solar at present. So these are all the challenges we have. So, so with these things, we understand that there is a need for solar energy, and these are all the drawbacks and challenges. So to effectively integrate these systems with the actual application of the industries. So that's why. So what is the thing? We have to develop a proper design for solar thermal systems for any industry. It may be processing agro or industrial process heating. So we must have a proper design guidelines. We must have to reduce the initial investment, and we have to create a lot of education and training, and we have to develop and promote the system for industrial usage. So these are all the challenges faced by the researchers and innovators, especially in solar air heating. Okay, so as a researcher, so what I do here means my area is how to design a new type of solar air heating system that is to be used for, that is to be integrating with existing greenhouse dryers to improve the efficiency, and the benefit should be enjoyed by Indian agriculture farmers to convert their product into value-added products. So that is my objective. So for the purpose, if we want to do all these things, we have to develop a new and effective, efficient system. So for the purpose, where we have to start? So we know that in conventional solar dryers, the convective mode of solar air heater is poor in performance. So I want to improve its efficiency. So if I make a design, if I modify a design, how I know the modification will give the useful output or not? So for the purpose, I develop my own mathematical model, whether if I change the existing design, it may give the suitable results, or it may enhance the efficiency of the system or not. So if you go for the actual experimentation, the cost will be get more. So for the purpose, we try to make a suitable analytical model or mathematical model, whether the system work or my idea will work or not. So for the purpose, I develop my idea. That idea will be converted into mathematical equations. Then the mathematical equations are converted into linear equations in mathematical model. Then these equations are solved under actual environmental conditions, and we will validate with the real system, and we may check idea is working or not. So that is the first step we are developing the analytical model for our solar air heaters. So what is existing? What is our new novelty? Look at there. So in existing collectors, so this is the simple solar air heater. So in the normal air heater, we have a very simple components. The first component is known as glass cover. Then the second component is known as observer plate. The third component is known as jet plate, and the fourth component is known as back plate. So what is meant for jet plate means the plate will be looks like this. It consists lot of perforations. Perforation means a lot of small holes. So this plate is attached here. Okay, in normal solar heater, the air is passing only parallelly to this observer surface. So what happens when the sunlight falls over the glass cover, through the gas cover and heat this plate. The plate is get heated. So once the plate is heated, if you pass the air under this plate, what happens? The air gets heated, it goes out. Very simple. Very simple. Ordinary radiation mode of heat transfer and convection mode of heat transfer, the air is getting heated. But if you use this system that means if you use this simple solar air heater, that means I have an air. So this is my observer plate. When the air is passing over there, what happens? A boundary layer will be get formulated like this. So this boundary layer will act as an insulator for my heat transfer. So the heat transfer will get reduced due to this insulation surface. That means this is the imaginary boundary layer. If you study the fluid mechanics, you know that how the boundary layer formulation will be happens when the flow is happened over the flat plate. So this will be act as an insulator. So to overcome the drawback, in our technology, we are inserting a jet plate in between my observer plate and back plate. Instead of parallel flow, I make the flow as perpendicular. Okay, I make the flow as perpendicular, and due to that, the boundary layer formation will be get reduced. The heat transfer will get improved. So that is the technology. It is already available there. Also in the market, it is available there. Okay, this technology already developed. But what we proposing here means, due to this impingement technology, the pressure loss will be higher. So instead of the single pass flow, we make it 2-pass flow in my air heater. That means in the upper surface, we are attaching the artificial roughness. At the bottom side, we have a jet impingement technology. If you pass the air on both the side of the hot plate, the efficiency will get improved. So this is what you have in the left-hand side. That is the idea already proposed by an IIT professor in 1996. So this is the idea I am developing. This is the system. So what is the drawback in 1996 idea means the higher pressure loss. The heat transfer is higher, but the pressure loss is more. But this system is developed by myself in the year of 2017 in my work. So I am proposing this system for enhancing the heat transfer. So I want to know, before developing an actual experimental model, I want to know whether the idea will work or not. So for the purpose, I am developing an analytical model to check it whether the system works or not. Okay. So you know that any system, if you develop any analytical model or mathematical model, we have certain assumptions. So I am developing these assumptions. So after that, so it's a very simple case. If you want to develop an analytical model, there are 3 equations are there. Only continuity equation, momentum equation, and energy equation. So if you write these equations for each component of your solar heater or water heater, then the governing equations will be comes there. So you know that in the world, all the systems are working based on some fundamental physics. if this fundamental physics are converted into mathematical form, those things are known as governing equations. If these equations are solved for actual boundary conditions, that is known as analytical modeling. Okay. So what is the physics here? There are various components are there. First component is the glass cover. So look at there. I have a glass cover here. So what is the physics in glass cover? As per the solar air heater means the energy supplied into the glass cover is equal to energy comes out from the glass cover. So this is the fundamental physics we have. Energy into the glass cover always equal to energy out. So how the solar, how the glass will get the heat? It only from solar radiation. So this is the first term will represents the energy inject to the glass cover from the sun. Then it also get the heat from observer plate from convection mode of heat transfer. Then it also get the heat from observer plate in terms of radiation mode of heat transfer. So this is radiation, convection and radiation. I write this equation based on the fundamental heat transfer problem. I write this in the left hand side. So how the left hand side 3 terms will represent the energy into the system. So then how the energy goes out? The energy goes out to the ambient and the sky with the help of radiation and convection mode of heat transfer. I will put those things in the right hand side. So energy in is equal to energy out. So this is for glass cover. In the same way, I have to write it for observer plate. In the same way, I am writing it for the jet plate. In the same way, I am writing it for the jet plate. And I am also, there are 2 airflow paths will be there. One is upper airflow path and the lower airflow path. I will write the energy balance equations for the airflow paths also. Okay. Then last one is back plate. So I have 6 components in my solar air heater. So I will get 6 equations. Okay. So once I have the 6 equations, these equations are called algebraic equations. These algebraic equations are write it in the form of matrix form. So then I will write it a code to solve this matrix in matrix inversion technique. Then I will get the results. So these are all the various formulas to be used to calculate the various convective and convective heat transfer and Nusselt number correlations are there. So with the help of these equations, I will calculate the various constant, that is constant and variables. Those things are required to solve the mathematical models. So once I solve this, I am calculating the thermal efficiency, hydraulic efficiency, and exergy efficiency. So I will calculate the thermal efficiency. That means how much energy is supplied to the system, how much energy is I'm converting as a thermal energy from my solar heater. Thermohydraulic efficiency means how among that energy collected, how much energy is consumed for pumping power. So that is to be subtracted. That is known as hydraulic efficiency. Exergy efficiency is that is second law efficiency. So what is the maximum possible efficiency when it is reduced to ambient conditions? Okay, so that is known as exergy efficiency. So I am calculating these efficiencies for already proposed system and my own system. Okay, so I am calculating. So these are all the dimensions of my system. So this flowchart, these are so I am developing the code. How the code will works. That flowchart is shown here. So look at that. The convergence criteria will 0.001 degrees Celsius. So with the help of this process, I am solving the equations. So once I solve these things, I will get the results. Okay. So look at that, the thermal efficiency of the system and the effective efficiency of the system for my thing. So look at there, this line. For an example, I will take this effective efficiency. Look at there. This is for simple system. These lines for my proposed new system. Okay. Why there are multiple lines in my proposed system means I am changing the roughness of my design. There are various designs I am using in the roughness. So from before go to the actual experimentation, I know that how much percentage of in my proposed system when compared with the existing system. So SPST means single pass single duct jet management solar heater. SPDD means single pass double duct jet management solar heater. So look at there. at the 0.01 kilogram per second, at this condition, my existing system will be 60%, but the proposed system with arc-shaped roughness will give around 70%. Okay. So with the help of that, before go to the analytical model, we are able to know that how the performance of the system will be. Okay. So that is the power of analytical modeling. So if you know the proper analytical modeling, we know how the system will perform, what are all the key parameters, what are all the dimensions to be fixed to get the maximum efficiency of those systems. That is known as optimization. So initially in 2017, I developed this type of jetty measurement solar aggregator and check its performance. Okay. So these are all the other graphs with various flow rates, how the useful energy gain will be there. If the inlet temperature is get varied, how it will be. What is the effective efficiency with the help of the length of the solar aggregator? Look at there. If the length is increased, the performance will be get improved. Okay. But up to certain case, if you go with 1 meter, look at there. At the what is the flow rate to be measured? So based on the temperature and heat output requirement from this data, I may able to select the length of the solar aggregator. So those things are did analytically. Okay. Then you know that in my solar aggregator, there are two passes. One is at top and another one is bottom. So what is the mass fraction to be maintained? At bottom to be higher or top to be higher. So in my simulation, I found that if you maintain it, both the sides will be equal. That means 50% of the flow in the top and 50% of the flow in the bottom, we will get the uniform efficiency. So those things we will get it. So after doing this analytical model, only we know that what is the dimensions to be fixed, and for the particular temperature, what is to be length and width to be fixed. All these things we analyze, then we develop the actual experimentation, and we develop the correlations for Nusselt number and friction factor. So this is the one type of solar aggregator we developed in 2017. Okay, but still there is some drawbacks. What are the drawback I am faced here means here also the flow rate will be around 100 kilogram per hour. If you go for the actual market, the 100 kilogram per hour is very low. It's very, very low for such a huge system. For an example, if you go for an solar dryers in the market, it goes 400 square feet to 1000 square feet. If you supply 100 kilogram per hour means when the dryer will be get heated. So that is a major drawback and challenge for us. So then I am developing another solar air heater. In this solar air heater, we are integrating. It's a rectangular solar air heater. So we are integrating with the fins and baffles. So you know that fins will enhancing the area and convective heat transfer to be increased. Then we are attaching a baffles. So if you have a fins and baffles, the turbulence will be get increased and the solar heater performance will be to be increased. So we developed this model also and tried the analytical model and how with the fins and without fins, with baffle and without baffle, what is the baffle thickness to be maintained, 5 mm, 10 mm, 15 mm, how the performance will be, all these things will be analyzed, and during the time, what is the efficiency will be. So from the results, we identified that arc-shaped roughness with the fin solar aggregator with the baffle thickness of 15 mm have higher performance when compared with other studies. But in the flatlet solar aggregators, the major drawback is we cannot able to go for much higher flow rate. If you increase the flow rate, the temperature will be get reduced. That is the major drawback, and also the pressure drop also to be very high. So to overcome this, so I am developing one more solar aggregator here to reduce the pressure drop. We have come up with a solar aggregator with a triangular shape. So if you go with if you compare rectangular and triangular ducts, triangular ducts have lower friction, so pressure drop will be get reduced. If the pressure drop will get reduced means the heat transfer will be same, but the pumping power will be get reduced. So my thermohydraulic performance will be get improved. So in earlier studies, they are only doing single pass solar aggregators. So I am integrated and I am developing a hybrid solar aggregator. In this hybrid solar aggregator, I have the bottom part of my solar aggregator is made up of triangular shape. The top part is made up of a rectangular shape, and also it have two covers. So why two covers means to minimize the radiation losses. So I developed this system, and also this system also integrated with artificial roughness for minimizing the for enhancing the convective heat transfer. So here we used inclined rib shape. It is attached at both top side and bottom side for enhancing heat transfer. So look at there, the result side. So the hybrid solar heater with rib roughness have the maximum efficiency of 80% at 0.035 kilogram per hour. So this is the maximum efficiency we obtained with this type of hybrid solar heaters. Right? Okay. So I request participants to kindly mute your mic, please. So this is the thing. So when so in 2017 to 2021, I worked most of the times. I worked with triangular duct and the rectangular duct solar heaters. So the major drawback what we found there means at higher mass flow rate we may able to get lower temperature. Okay, so that is a major drawback. So then only in 2021 itself we are come up with one more idea, that is how to use the evacuated tubes for solar air heating applications. Before also some people are working there, but we are also using the evacuated tubes here. So what is the major advantage of evacuated tubes? The evacuated tubes absorb the maximum solar radiation even though the position of the sun. Okay, it gets maximum, and also we may able to heat up to 300 kilogram per air at 360 degrees Celsius. At higher mass flow rate, we may able to heat the air. So that is the objective. So for the purpose, we conduct one study, this type of evacuated tubes with the 20 tubes of evacuated tube, and we are inserted various turbulators inside and how to get its performance. Okay, so that is the thing we did it. So here also we get one more problem. Look at there, 50, 100, 150, up to 100 to 150. Then the pressure drop will be due to pressure drop, the efficiency will be get dropped. Okay, so when you use ordinary evacuated tubes are used previously for water heating application. It is a cylindrical tube. It is coated with the special coating for observing the heat. So this is a simple glass tube. There are two glass tubes will be there, inner and the outer one. So in between the vacuum space will be there. So you know that the radiation heat transfer is the fastest mode of heat transfer even in the vacuum space. So that's why it will be heated in a very faster manner when we compare with the ordinary flat plate collectors. So that's why its performance is good when we compare with the ordinary flat plate solar heaters. This will be more suitable. So that's why again I analyze the systems with the various configurations of twisted tube for enhancing its efficiency. But so all these things. So how we do these things? Simple solar heater, jet Benjamin solar heater, triangular jet solar heater, evacuated tube solar heater. All these things initially we do it only by analytically. Then once we will get the fruitful results, then we go for the experimental results. So that is the thing. So if you want to develop your idea into proof of concept, this type of simulation tools are very, very essential. You may develop your own codes in MATLAB, or you may go with the CFD analysis. So your idea work or not. So I develop this work as a proof of concept. So once I develop this proof of concept, and I publish these papers in solar energy, renewable energy, applied thermal engineering. So all these works are published in elsewhere publications, right? But all these things will be some proof of concept. Then so in a startup, what is our next stage? The proof of concept to be converted as a prototype. That is actual experimentation. Okay. So if you want to do any experimentation, we need grants and funds. Okay. So so in 2022, I developed all these systems as an analytical model, and small experimental setup is in my institute. So during that time, Ministry of Consumer Affairs announced a challenge known as Onion Grant Challenge. In that one, they require a dryer, especially for onion drying. They need much efficient drying solution. So that's why that is the initial a small grant obtained by us. We won Onion Grant Challenge in 2023. That is to convert our idea into proof of concept and proof of concept into a prototype. So what is the idea we proposed there means? So look at this slide. So we integrate the evacuated tube with the jet management technology. So in the solar air heater, if you use turbulators, the pumping power will be high. Even though the output temperature is good, the pumping power is high. So instead of turbulators, what we propose to them in onion grand challenge, the air heating will be did in the evacuated tubes with the help of jet management technology. So we will get the hot air for 300 kilogram per hour of air at 60 degrees Celsius with low pumping power consumption. Then this hot air is distributed to my dryer inside the dryer for effectively drying the onions. So that is the proposed idea for Ministry of Consumer Affairs. So the Ministry of Consumer Affairs give only 75,000 rupees to develop the air heater for us. Okay, so with the help of that one, we developed the solar air heater. Then in the second round, they gave 2 lakh rupees for us to develop a small prototype. Okay, so that is the first stage of our innovation. So initially only we have published the paper, then that innovation to be converted as a small prototype with the support of Ministry of Consumer Affairs through an Grant Challenge. So after that, in 2024, AICT announces Yukti Innovation Challenge to convert your proof of concept into prototype. So that's why we are integrating. Initially we have only 10 tubes. We are modified into 20 tubes. Initially we have 1 HP blower. Now we may add 3 HP blower. Initially we are not having variable frequency drive. We are attaching those systems in my solar air heater. So we may convert our proof of concept into a prototype with the help of Yukti Innovation Challenge announced by AICT. So the idea is converted into prototype with the help of the grants and funds given by AICT. Then after that, during that time, we know that another innovation challenge announced by Tamil Nadu government. So in Tamil Nadu government, there is one program called TNRTP. What is meant for TNRTP means Tamil Nadu Rural Transformation Project. In that, what is the goal of this project means? Under this project, the Tamil Nadu government collaborated with the World Bank. They identify the challenges and business issues faced by the self-help group in the entire Tamil Nadu. So among that, one challenge faced by in Thoothukudi district, the self-help group want to dry the water hyacinth waste. Okay, you know that water hyacinth is available in our lake. So it will be spoil our lake environment and our ecology. Why means if the water hyacinth is present in our water, we will not use, the oxygen level will be get reduced. The fishes are not to be surveyed in the lake. Why means the O2 level will get reduced. So we have to remove the water hyacinth. So that self-help group take that water hyacinth stem, they are converting into a value-added product like mats and penstat and other products. So they have an issue. If they want to dry the water hyacinth in an effective manner, they need a dryer. Okay, otherwise it takes 10 days to dry. Okay, suppose rain comes means immediately entire thing will be get fungus. It may get damaged. Then after developing the product, it is converted into a mat or anything. Then also there is a varnish coat will be there. So once they do the varnish coating, again the product to be dried. Okay, otherwise if you go with the ambient, if the temperature is not good, the finishing will not come. So for that purpose, they need the dryer. So that challenge given by the World Bank. So we already have, with the help of AICT, we already developed this dryer. So I take water hyacinth from local lake and I checked whether in my dryer it is dried or not. So in my dryer, it dried within 3 days. Okay, initially they are working for 10 days. So at present, the dryer will work fine to dry the water hyacinth. So we pitched our idea under Tamil Nadu government with the World Bank support. So we won idea for change challenge. So the first product to be commercialized, our first dryer is installed at Thoothukudi district. As a product, we sold out to Tamil Nadu government with the grant the granting aid support by the World Bank. So that is the thing. So initially our product in the lab we are supplied into the market, especially the Tamil Nadu government is my first customer. Okay, so that is the first stage we are passed out there. So then after that we won Tamil Nadu government TANSEED grant and IIT Kanpur's Social Innovation Lab program for further development of our product. So at present, what we are doing means, at present we are developing the solar dryers, especially for the farmers. Okay. So what is the problem we are solving here means, we want to reduce the post-harvesting losses happens in agriculture industries and value-added product manufacturers. This so when the problem will occur for our customer is during Kharif and late Kharif period. So what is our idea? What is our idea when compared with the existing dryers means, we are using jet measurement technology within evacuated tubes to produce the enough hot air and supply it into the greenhouse dryer to get the uniform temperature. Okay, so that is the thing. So if you use this technology, what is the benefit to my customer? Look at that. So if you use this technology, the space reduction may attain up to 32%. The drying time may be reduced to 26 to 40%, and the production cost will be reduced by 28%. And also we are having DOS system and NOS system to reduce the payback period of our customers. Okay, so this is the system proposed. Our technology readiness level is assessed by Amrita Technology Enable Center, and our technology jet management solar air heating technologies get patented, and the patent will be granted on 2024. So at present we are in the technology readiness level of 8. Okay, so this is the flow chart of our product, that is Shiny Jet Agri Dryer. So we have a blower. The blower able to supply 100 to 300 kilogram per hour. So the air will be heated up to 50 to 70 degrees Celsius. Then the hot air is supplied to the solar air heater. With the help of air distribution system, the uniform air will be supplied. So at present we are dried onions, moringa leaves, water hyacinth for the effective drying. So after drying, we check our product in the lab whether it have a sufficient nutrition and shelf life will be there. We checked all these things in the laboratory conditions also. So it works fine. So that is the stage. In this way, our system will work. So after doing all these things, we install. This is the system. The first figure. We sold out our first product for 8,80,000 rupees for Agaya Tamarai Malar Utpathiyalar Kulu under the support of TNRTP. The plant is located at Thoothukudi. Then our second product is sold out at Kirakade Ventures Private Limited, Madurai. So you know that the Kirakade Ventures Private Limited, they are producing soups from various pinches. So they need the dryer to dry all these agro products. So the company head office is located at Coimbatore, and the manufacturing unit is located at Madurai. So we install this dryer at Madurai. That is the second plant we installed. Our third plant is installed at Manju Flowers. So the Manju Flower, they are producing health mix and they are exporting those things. So they need one dryer. So we installed in their company's upstairs, we installed 100 square feet dryer for drying the various agro products. So this is the third installation we completed. So at present we are working with Perfume Drops Madurai. So Perfume Drops is a company. They are taking perfume from flowers. Okay. So after taking perfume, the waste product, the waste flowers will be in highly wetted condition. So we have to dry it. After that only it is to be converted as an other value-added products. So for the purpose, that company need a dryer. So we are working with them. Then Meena from Rajasthan, they already have a solar dryer. They request for us for how to connect the air heating system. Kumbhigagas is another company located in Assam. They are producing paper from water hyacinth waste. So they need paper drying purpose. We are working there. Green Atmosphere Mysore, that is another company. That company doing at Mysore, there is a special type of banana will be there. They want to convert those banana into a food products for newborn babies. So how to dry the ripened banana and unripened banana. So for the purpose, the company connected with us. They gave a lot of products to us to dry it in our pilot plant. So our pilot plant is at present located at Coimbatore. If anybody want to check or you want to dry, contact us. So we will do drying operation in our pilot plant. In Mysore, every week they are send banana in the bus to Coimbatore. So we dry it, we send it back. So at present, they are in the testing stage to convert, how to convert this raw banana and ripened banana into a value-added products. So these are all the various customers we are connecting. How our innovation to be converted as a value-added products for the agro product development companies and the farmers. Okay, so these are all the other products at present in our development. So look at the first figure. So when we developing in solar dryers, we know that there is a huge market for smaller dryers, 20 square feet, 24 square feet. So we designed that type of shiny cab agri dryer. So that is to be given to the smaller value-added product manufacturers. At present, we sold out nearly 7 such type of system in Coimbatore, Virudhunagar, and other parts of Tamil Nadu. Okay. Then at present we are increasing the number of tubes. Instead of 20 tubes, we are installing 40 tubes to get the maximum air heating temperature for other applications. And also, one of the major drawback of solar dryer is it is not working in night time. So at present we are connecting with electric heaters, infrared heaters, and heat pumps, integrating with this type of greenhouse dryers for night drying applications. Our dryer to be worked on all the 24 hours. Look at that, this person, the third photograph, his name is Saktivel. He is cultivating nearly 12 acres of moringa in his farm. So he need dryer. The dryer should be worked for entire all the 24 hours. That is the requirement by the customer. Why means he have 12 acres. Per acre, they will get 4 tons of moringa leaves. So if the moringa leaves is produced 4 tons, immediately should be dried. So my dryer to be worked for all the 24 hours. So that's why we make our pilot plant. We check in our pilot plant whether the system will work for all the 24 hours or not. So that is the one more system. Then we are also connecting at present with Canapex. You know that Ramanathapuram at Tamil Nadu, they have a special variety of chili. So they need the dryers for chili drying. So at present we are checking with Canapex how to utilize our dryer for drying of chili in an effective way. So Ramanathapuram chili also geotagged chili. It has some special value to produce chili in sambar. So how to use the chili, especially in sambar. So the chili it will not used for chili powder. It is as a whole. It is a dried chili. We have to use it in sambar. So for the purpose, we are connecting with the Canapex how to use our solar dryer for chili drying also. Okay. So these are all the innovations are developed by our company. So that's it. Now the session is open for the queries. So if you have any specific queries, you may ask now. Sir, that's it from my side.
Yes, sir.
Yes, sir. So now if you have any specific queries, you may put it in your chat box, or you may ask. Kindly unmute your mic and ask your questions.
The forum is open to the participants. You can trigger out your questions to the resource person. So it is a very crystal clear presentation about the solar dryers used for the agricultural purpose, sir. Right from the scratch, you have presented everything up to the level of PR level 8 and how to pitch it in the market. Everything explained in a clear way, sir. Hope the participants gained a greater insight about it.
So
any further queries? Questions are invited. Questions are invited. The feedback form is shared in the chat box. All are requested to fill the feedback.
So actually our pilot plant and our research lab is located at Coimbatore. So any of the researchers want to collaborate with us, we are inviting you to collaborate with us. If you want to do any testing in solar air heaters, or dryers, come and use our facility. Or if you are come from food product background, if you want to develop new innovative food products, ready to eat or ready to cook, such type of products, we welcome you. We already collaborated with that company known as Green Atmosphere. They are developing baby products, especially from banana. So if you have such type of idea, come and utilize our facilities.
Good evening, sir. Good evening,
Yes,
sir.
please, sir.
Good evening, sir.
Yes, sir. Sir, is there any opportunity for our institute students to use your facility in line with their project work, sir?
Yes, sir. Yes, sir. Yes, sir. So, if you have an any idea, if you want to do any design modification in solar air heating or solar dryer, you may. There is a test rig will be available there. So you may come and if you come there, you may connect your proposed system, or you may do certain modifications. You may come and do it there. So we have the testing facilities with all the pyrometer and all other accessories for to carry out the performance study of solar dryers and solar air heating systems. So it is permitted. So I will share my mobile number and mail ID in the chat box. Kindly contact us for doing for further collaboration, sir.
Sure, sir. Thank you, sir.
Any other questions from the participant side?
So I
Dr.
posted my
Matheswaran
mail
is a
ID.
multifaceted person. He's
posted
a
my-
professor in an institution, and he's also an entrepreneur. He's the director of the company Shining Solar Technologies Limited. He's also doing some edible eatable powders. Am I right, sir?
Yes, sir. Yes, sir. So at
Yeah,
present,
he's
so we have a pilot plant in my institute. So for that purpose, we understand that there is a huge value for solar dried products. So so with the help of my dryer, I am we are starting with local people. We are converting moringa into soup and idli powders and sambar powders. That is to be benefited for the local community. So at present, we are doing such products. So then only so the first step of innovation development is empathy. So if I use my solar dryer to develop a food product, then only I know what are all the problems faced by my customer. So that's why we are developing such a products to understand the customer's problem in a better way. So so at present we are developing food products also.
Yeah, thank you, sir. Thank you. Thanks a lot. I hope no other queries from the participant side. It's a very crystal clear presentation. Thank you so much for sharing your valuable knowledge with us, sir. If there are no other questions, you can wind up the session.
Okay, sir. So on behalf of Department of Mechanical Engineering of Janssen Stuff Technology, and my own behalf, I thank the organizers and the management of Adi Shankara to inviting me and give this opportunity to share my views in the area of how the solar energy is to be utilized for industrial process heating, especially in agro processing. Thank you. Thank you all.
Thank you, sir. Thanks a lot.